Hi, welcome back. In today's video, we're going to talk about bisectors of triangles. In particular, a perpendicular bisector and an angle bisector. We'll talk about what these two are and some examples from Schoology for each of these sections. If at any point you find something here that is useful, go ahead and hit the like button. And if you haven't subscribed so already, go ahead and do so right now. Let's start by defining what a bisector is. A bisector is when you cut something into two equal sections, right? Two sections, bisectors, two sections. So we're going to be doing a perpendicular bisector and an angle bisector. Let's get right to it. Here, let's start with perpendicular bisector. Now, perpendicular, if we think back to the symbol of perpendicular, means that it intersects a line at 90-degree angle. And if it's going to cut it into two equal sections, then we're going to do that for every segment. So let's start with segment AC. We have the segment AC. We're going to intersect a line with this one at 90 degrees and cut it in half. So I'm going to put a point somewhere here. I want to draw a line that comes 90-degree angle straight down. Something like this. It meets 90 degrees and it cuts each segment into two congruent pieces. So now AC is cut in half and this line intersects it at 90 degrees. We're going to do that for every side. We're going to look at BC and AB. I'm going to use different colors to help you identify the differences. If we're looking at BC, we're going to cut this segment down the middle, also at 90 degrees. So now these two segments are congruent. And we're going to do something very similar to BA. BA is our last side. We're going to cut that one down the middle as well. And it's going to meet at 90 degrees. So this segment should be congruent to this segment. That's the first big property of a perpendicular bisector, is that each segment will be cut in half, making this equal to each other, this equal to each other, and this equal to each other. This last word here is called the circumcenter. Circumcenter is where all of these perpendicular bisectors intersect, that point right here. This is the circumcenter. Now, the circumcenter has a very particular rule or property within a triangle. I'm going to draw another line, a dotted yellow line hopefully, that connects the circumcenter to every vertex. To A, to C, and to B. These yellow lines, because they're the circumcenter, are all going to be congruent in length. So the circumcenter to each vertex will be the same size, the same length. All right, let's do an example here in a little bit. But first, let's talk about angle bisectors. An angle bisector, now we're going to be cutting an angle into two equal parts, right? Now an angle bisector, we will cut each angle in half. So let's start with A. We're going to cut this angle down the middle, somewhat like this, making those two pieces congruent. So that's going to get cut in half. And we're going to do that for every angle. So let's go to angle C. Angle C is going to get cut in half. Now those two angles are congruent. And same thing with angle B. Now those, Now those are going to be congruent. Oh man, I'm working. My OCD is killing me here for a second. Somewhat. Okay, so first big property for angle bisector is that each angle will be congruent because it's going to be cut in half, cut in half, cut in half. This next word is called the incenter. Incenter, you guessed it right, is the point where all of them intersect. That point right there is called the incenter. Now, the very particular property that this sensor speaks with is that that point, if we were to imagine, let's say, a circle that connects all of this, or even inside this triangle, will be in the center of the triangle. So if we're drawing a circle around that connects all of these 3 points, okay, or if we draw a circle even inside it. If we draw a circle, I'm going to try to draw a circle here as best as I can. That's not a good circle. That's even worse. Anyway, let's just pretend that we have a circle right in the middle. From the distance from the incenter to the side of each side of that, of this beautiful circle that you can see, this is terrible. The distance from here to each side should be the same length. Okay? So from the incenter to each side, it's also known as the radius of this circle that we're drawing. Okay? Every distance to each wall will be congruent. Maybe an easier way to think about this. Let me just erase this completely. Is that since we have this point in the middle of the line, it should be halfway to both sides of this triangle, right? I have this triangle here, and I have this side over here. This point should be equal distance to both sides. If I'm looking at the rest of the triangle, no matter how you look at it or which line you're focusing on, so we're focusing on the red line, then from here to this side and to this wall should be congruent. And then if we're looking at the green line, from here to the side and here to the other side should also be congruent. Okay? So the distance from the incenter to each wall should be the same length. Let's just keep it simpler like that. All right, let's recap to sort of simplify this a little bit. Angle bisector does 2 things. Well, one thing, it's going to cut the angle in half. Each angle will be cut in half. Then the incenter does another thing. It's in the center of this triangle, so it makes the distance from the center to each side of the triangle the same distance, the same length. So you can imagine a line from the incenter to each wall being congruent. All right, let's just see how this works out as examples. Again, I'm doing some examples here on Schoology. So here I know I'm dealing with a perpendicular bisector because I have a line right here that meets line OU right down the middle at 90 degrees, and there's 2 little tick marks, which means it's cutting this in half. This is congruent to this. I'm interested in finding the length of VU, the length of this segment. Okay, I want to know how long is this piece if these 2 are congruent. So I know that these 2 are equal to each other, and that's how I make my equation. 7x plus 2 is equal to 3x plus 10. So I solve for x by moving everything to one side. I subtract 3x on both sides. I have 4x plus 2 equals 10. I move the 2 to the other side by subtracting 2 on both sides. 4x equals 8. And divide by 4 on both sides to leave x by itself. So x equals 2. Now I'm interested in the length of VU. So that means that I have to plug this here where VU is at and we can solve for this value. VU is this segment. So I have 3 times x, which is 2, plus 10. 3 times 2 is 6. 6 plus 10 is 16. Voila. The biggest thing that told me here what to do is the tick marks. This tick mark is congruent to this tick mark. So I made them equal to each other. And then I solved. And I plugged it back in to find the length of VU. Let's look at another example of perpendicular bisectors. Now here I know that point L is the circumcenter. Point L is the circumcenter, which means that each distance from here to each corner should be congruent. And I'm going to draw that in a different color. So from here to each corner will be congruent. So we can start by looking at those segments. So BL, which is the circumcenter, right? BL should equal to LT and should also equal to the other one, LK. These are the blue lines. Now, because we're dealing with a circumcenter and we're dealing with perpendicular bisectors, each segment is going to be cut in half. So BN is going to be cut into 2 equal pieces. Sorry, BT will be cut into 2 equal pieces, which means BN is congruent to NT. If I wanted to also check, this segment will be cut in half, making HT equal to HK. This one's going to be cut in half, making BG equal to GK. For this last example, we're dealing with angle bisectors. Since I know this is point A is the incenter, I know several things. Okay, I know that this line, right, going to the vertex will cut each angle in half. Meaning, if this is 32, then this piece should also be 32. I'm going to put 32 right here. That angle is 32 degrees. If this angle up here is 21, it means that this angle is also 21. And then over here, this should be equal to this. So we have this value that we have missing should be equal to each other as well. So let's find the measure of angle YLA. YLA, I'll do this in yellow. YLA. That angle is, as you can tell, 32 degrees. Now I want to figure out the angle of YGA, which is, I'm going to do it in green, YGA, that's this little corner, one of the x values. One thing you can do is, because we have 2 x values, one big angle that's being cut in half, is you can add up all of the angles here and add them up to 180. So this whole big triangle, right, we can add them up and set it equal to 180. So angle Y, before it was cut in half, was 42 degrees. That's angle Y. Angle L was 64 degrees, right? 32 plus 32, 42. And then over here, we have some other angle that we're going to be dealing with. So all of these 3 angles of a triangle should add up to 180. So if I'm trying to set up some sort of equation, I can say 64 plus 42 plus some angle equals 180. And I can find what's missing, right? If I combine 64 and 42, I get 106. I'm trying to figure out what this angle, this thing is angle C. Right? That's what I'm trying to find, this big angle. If I subtract 106 on both sides, x equals, let's see, 72 degrees, 74. Yeah. Yeah, this should be 74 degrees. That's angle C. Now we're only interested in this angle, which is half of it. We're interested in this piece because it's getting cut in half. So we divide this by 2 and we get 37 degrees. Right? Because angle G is going to be cut in half. Right there. All right, I hope this has helped. If you have any questions, please let me know. Comment below, I can answer them for you. Again, if this video was helpful or useful in any way, click the like button. And if you haven't subscribed already, go ahead and do so right now. All right, everyone, we'll calculate later.